last one. This is another tricky one. I don't find there to be quite as much work to it, but will you see it? There's our little substitution. So, oh goodness, what is this? What is this? Well, what we're going to do here is we're going to need to deal with, it's got to be something underneath that square root. And the game is going to be by completing the square. So I'm going to take this denominator out, or what's underneath the root. And let's write it like this. You see that, how I just factored out the negative and then put it in descending order? Cool. Cool, cool, cool. I'll put an equal sign here. Now we want to create a perfect square. So when we look at this, we're like x squared. Don't look at the 3. X squared plus 2x. We look at our b. We're going to take that b, we're going to cut it in half, and we're going to square it. Half of 2 is 1. 1 squared is 1. So we're going to give this a 1. Actually, we subtracted 1. Do you see that we subtracted 1? So we need to actually counteract it by adding a 1. So this turns out to be 4 minus x plus 1 all squared. That we can deal with. So let's go back to our integral. So I think that's the tough part of the problem. After that, it's actually reasonable. Okay. There it is. So we're going to need to create some sort of substitution here where let's do a u sub real fast. Let's do a u sub. Let's not do the trig sub because we don't want that x plus 1 in there. So let's say u is equal to x plus 1. Therefore, du is just equal to dx. And also, we're going to have to take care of that numerator. So x is going to be equal to u minus 1. So let's go through and replace. So down below, we have 4 minus, and now that's just u squared underneath that root. And then up top, we replace our x with a u minus 1 du. Now we're set up to do a trig sub. We have an a minus a u squared, or an a squared minus a u squared, so that means we're going to use a sign. So we're going to let u equal, not 4, but the square root of 4, so 2 sines of theta. Du is going to be 2 cosines of theta d theta. Okay. Now remember, we're going to need to make a triangle out of this thing at some point in time. We can only be in the first or the fourth quadrant. Let's draw it in the first. Let's move our stuff over, divide the 2, and we say that sine of theta is equal to u over 2. Therefore, the opposite is 2. The hypotenuse is 4, and this has got to be 4 minus u squared underneath the root. Just thought we'd do that real quick. We'll need it later. Might as well do it now. All right. So up top, we're going to replace our u with 2 sines of theta minus the 1. And then we have the square root of 4 minus, and I'm just going to write it in as 4 sine squareds of theta. All right? You know that's where it's going to go, don't you? Skipping some of those steps. Now we can take out this 2, leaving you with the square root of 1 minus sine squared over 2 sines of theta minus 1 d theta. And let's take out that 1/2. Let's write the 2 sines of theta minus 1. And of course, the square root of 1 minus sine squared is just going to become cosine of theta. All right, that's the square root of cosine squared. Square root of cosine squared is cosine if we're in the first or the fourth quadrant. Now we're pretty much just there. I feel like I forgot something. I feel like I forgot something. Why didn't you tell me? Notice how oh man. I forgot to replace in the du. Oh, that's 2 cosines of theta d theta. That's 2 cosines of theta d theta. That's 2 cosines of theta, d theta. I forgot to punch them in. Oh, man, I was silly. I'm sorry about that, y'all. That makes life a lot easier. Oh, my goodness. Look at that 2 cancel with the 2. Look at the cosine cancel with the cosine. And now we just have the integral of 2 sines of theta minus 1 d theta. Sorry about me forgetting to plug that in. I mean, accidents happen. So now let's take an antiderivative on this. And we're going to get, what's that, negative 2 cosines of theta minus theta, all plus c. Well, let's go get it. Let's go sub in. Let's go find out. So we're going to have negative 2 times, now what's cosine of theta? That's the adjacent over the hypotenuse. So the square root of 4 minus u squared all over 2 minus, we're going to have to get that theta out. So theta's got to be equal to inverse sine of u over 2. So there it is. Okay, good. We're done now, right? Once we cancel those out, we got to be done, right? Did we start? I'm just curious. Did the problem start with u's? No, it didn't. U is equal to x plus 1. So everywhere we see a u, we need to replace it with x plus 1. There we go. Oops, I lost my inverse. And there it is. In all its glory. Look how beautiful and clean. That's not clean. That's just a gross thing. And if you were to mess with this, if you went down to it, you'd end up with 3 minus 2x minus x squared. That thing that we started with at the very, very, very beginning before we manipulated it. Oh my goodness, huh? She wanted to be a STEM major. That's a lot. This video and the last one, these are tough. They might be a little above and beyond what you might see on an exam. Maybe not too much further, but yeah, no, these are certainly challenging. You know, I don't blame you for struggling through some of these, and just do your best to catch what you can. Maybe you didn't catch the whole problem, but maybe you picked up on one trick. Then you're 1% better than you were the day before. And that's all we can really ask for. You're not going to figure everything out all at once. We just get a little bit better every day. So, yeah, buddy. Sorry, I listen to too much sports. That's what the athletes are always say. Just get better every day. Just keep putting in that work. It might be cliche, but that shit works. Well, that's the end of trigonometric substitution. So aren't we excited? We get to get away from trig. We can go back to algebra now. We're going to go back to algebra into, what is it? Oh, it's just partial fraction decomposition. Right back into algebra. All right, see you in the next section.